welcome to live lab number 6 on time series analysis in the cloud, especially in AWS. Today we will be building a time series prediction model to predict the demand of some items in a store. So let's imagine we are a big retail company and we have several stores in a specific region or around the world. We have the same items in those stores and we would like to predict the demand based on the historical demand over a certain amount of years. Okay, so actually from 2013 to 2017. Okay, so first, before we go into the console and start everything, let me explain to you the dataset. So the dataset, which by the way was shared to you in the event, is composed of 5 datasets, 5 data. First, you have the tiny data, which only contains 1 year, 3 items in one store. Okay, so basically the historical demand of 3 items during 1 year, 2017, in one store. Then you have the small data, which will contain the historical demand of 3 items in one store from 2013 to 2017, therefore during 5 years. Then you have the medium-sized data, which contains the historical demand of 50 items in one store during 5 years, same from 2013 to 2017. Then you have the big data, which contains the historical demand of 50 items in 10 stores during 5 years, same from 2013 to 2017. And then you have the huge data, which contains the historical demand of 50 items in 10 stores during 5 years from 2013 to 2017. And plus you have a training and test set. Okay, so in order to work on the huge data or big data, well, it would take us a couple days. You know, we cannot fit this into a 1 hour or 2 hours lab. I don't know how long will be this lab, but yes, there you go. We can't really work with those. And in order for us to, for all of us to be able to build the application, build a predictive model and finish this lab successfully, today we're going to work on the small data, which is still quite big. If you open this demand forecasting.csv with a text editor, and there you go, you will see several columns. So the first column is item ID, meaning the ID of the item for which you want to predict the demand in 2018. You see, we have the historical demand of the item from the 1st of January 2013 to, if we scroll down, during 5 years up to, there you go, as you can see here, 31st of December 2017. That's for the first item, all right? And for each of these days, so it's a daily frequency, for each of these days we have the number of sales, okay, for this particular item. And we have the same for 2 other items from the exact same period, from 2013, 1st of January to 2017, 31st of December. That's for item number 2. As you can see in the left column here, we have the item number 2, item ID 2, okay? And we have the same for a third item of item ID 3 for the exact same period from January 1st, 2013 to December 31st, 2017, okay? So we have this historical demand with a daily frequency for 3 items in one store. Therefore, there is not the column store here. We don't need it because we are in one store. For this period going from January 1st, 2013 to December 31st, 2017. If I show you, for example, the bigger data, like big data, you will see an extra column for the store because for this big data, we have 10 stores. So if we open this, as you can see, we have this extra column here. We have the same columns as before, item ID, timestamp, which is a daily frequency giving you every day the demand for this particular item. But here we have this extra column, this extra dimension giving the store. And so as you can see here, we have, the historical demand with a daily frequency for 50 different items actually, and for different stores. So this is for item number 1. And as you can see, we have it in different stores. This is store 8, number 8, and then store number 9. Okay. And we have this for 50 items in 10 stores, in the same stores from 2013 to 2017. Okay, but this would take us days, to build a powerful time series prediction model for this, and that's exactly why we are going to work with the small data today. However, in the service that we're going to use, which is Amazon Forecast, I will show you how to add this store column in the framework, okay? So I will show you this, but we won't apply this, all right? So let's go back. Let me go back here. Do we have any question about the dataset? Is that clear? Is everything clear about the dataset and about the case study before we start? Yes, clear? Oleg, thank you. Okay, perfect. So I'm going to move on to now the console. All good, Jaren? Okay, perfect. So now I'm going to move on to the console. So first, because the principle of those live labs is that they must be very interactive. They must be made in a way that everyone should complete the lab from start to finish. So my first question to you is, are you all connected to an AWS account? In the description of the event, I give you the link on how to set up an AWS account. It takes 5 minutes and it's free. And of course, I will warn you about any charges that might occur today. So I will tell you to stop at some point if you don't want to get charged at all, okay? But if we look at the Amazon forecast pricing, let's have a quick look at it. You will see that it's actually free for the first time you use it. If you use it for the first time, I think it's free. Let's have a look at here. Yes, there you go. Free tier. So if you just created your AWS account, therefore a free tier account, well, know that Amazon Forecast is for the first 2 months of using Forecast, customers receive up to 100,000 forecast data points per month, up to 10 gigabytes of data storage per month, and up to 10 hours of training per month. I can tell you that with what we're going to build today, with that small data, for sure, this is going to be free. Everything is going to be free. But you have to make sure that you have a free tier account for less than 2 months. All right? All right. Just wanted to give you the pricing heads up. And now let's get started. Okay. So welcome to the console home. And yes, I was asking if you all are connected right now to the AWS console home. Yes, Oleg, you are in the service console. Perfect. Okay. Is that the case for everyone else? Or does anyone need help connecting to the AWS console? Yes, Jaren? Okay. Awesome. Awesome. I hope it's the same for you, Avanish and OI. Okay. Avanish, same. Perfect. Great. So let's get started. All right, so first we're going to go to Amazon Forecast. It is in my recently visited services, but I'm going to show you how to find it in the search. You type here forecast, as simple as that. Amazon Forecast in the services. Amazon Forecast is a fully managed service for accurate time series forecasting. Perfect. So we go to this one, Amazon Forecast. Amazon Forecast, welcome to Amazon Forecast. Easily build accurate forecasting models. Amazon Forecast is a fully managed service that uses machine learning to deliver highly accurate forecasts based on the same machine learning forecasting technology used by Amazon.com. So basically, Amazon Forecast contains some state-of-the-art time series predictive models which will give you much better results than the classic ARIMA models, okay? Actually, in Amazon Forecast predictive models, they contain the ARIMA models because usually what AWS does is that it takes an ensemble of powerful predictive models and through a voting system or through an ensemble learning algorithm, it will give you the best results, okay? So the first thing we're going to do now probably in the button here, you have create a dataset group. That's the very first step. I already created some dataset groups before, so I have view dataset groups. So I'm going to do view dataset groups. And because the training, even if we choose the small data here, even if we choose the small data, the training is going to be quite long, because it's an ensemble learning of several models. And therefore, I already did the lab for you. Because the training is going to be pretty long, well, I already did the time series prediction training. Okay, I already trained the model so that I can show you the results even within this lab in 1 or 2 hours. Okay, so I already did this. But now what we're going to do all together is the first step when you use Amazon Forecast, which is to create a dataset group. So let's do this. That's exactly our first step. Okay, so first we give a name to the dataset group, and you will see that the dataset group is, the whole framework where you will have your data, while you will have your time series prediction model, and while you will have your forecast. You will see we will have a nice dashboard containing all these things, and this will be the dataset group. Okay, so let's call it demand forecast dataset group. Okay, demand forecast dataset group. Then we have to choose a forecasting domain. A forecasting domain defines a forecasting use case. You can choose a predefined domain or you can create your own domain. All right, so now according to you, which one are we going to choose for our case study? Is it going to be retail, custom, inventory planning, EC2 capacity, workforce, web traffic, or metrics? Please let me know in the chat. So I always make this labs as much interactive as possible. So oftentimes I will ask you some questions and please answer in the chat. So according to you, which use case is this? It's important to choose a use case correctly because then it will give us the right format of what should be expected in terms of the data. Yes, Joran, you are absolutely right. And Hawaii too, you're absolutely both correct. It is indeed retail. So here in forecasting demand, we are going to choose retail because, as it says here, this is a predefined domain for forecasting demand for a retailer, which is exactly our situation. Remember, we are a retail company containing several stores. We have several stores around the world. And in these stores, we have the same items. We have the historical demand for these items. And we're trying to forecast the demand for the next year after 2017, meaning the demand of these items in 2018. That's the case study. So that's a typical retail case study. Okay, so we choose retail here. Then no need to give tags. We can click next. And this will already create your dataset group, demand forecast dataset group. All right. Okay. So now the next step after creating a dataset group is to import the dataset. Forget about this target time series dataset. What really is done here is to import the dataset. But now the question is, where are we going to import the dataset from? Is it going to be from our machine or is it going to be from somewhere else? New question I'm asking to you. According to you, where are we importing the data from? If any of you has some knowledge or experience in cloud computing, you will know. Yes, Darman, correct, totally correct. In AWS and in cloud computing in general, we never import the data directly from our machine. We always import it from S3, which is the simple storage service of AWS. The only service of AWS where you will import the data from your machine is actually S3, because that's how you create a bucket and that's how you populate the bucket with some data. So the next thing we have to do now before importing the data in forecast is to actually create a S3 bucket where we will put our data from our machine. Okay, so here in the search, I'm going to enter S3 and be careful, I'm going to open S3 in a new tab so that I have one tab for Amazon Forecast and one tab for S3. Okay, and because I did the lab by myself first so that I can all show you the results at the end, and I call this exactly the same as what we're going to call our names, but I added had solo at the end. Okay, so now we're going to create a new bucket. All right, so make sure you're all in S3 and you go to the create bucket button and you click on it. So create bucket. Okay, I'm just making sure everyone is all good. You please stop me in the chat if I'm going too fast or if you missed a step, anything. And you also can, feel free to unmute yourself and tell me stop, I missed a step, please go back, please rewind. Okay, this is supposed to be a live lab where we all build the application together from start to finish. And for me, a lab is successful if everyone at the end of the lab successfully build the application. Okay, so let's go back to S3 and please unmute yourself and say stop if I'm going too fast. So now create bucket, yes. General purpose, yes. We're going to create it in the US East 1 region, which is the default region, but maybe you got another one. Anyway, S3 is a global service. That doesn't really matter. What matters here is that we choose a bucket name. So we're going to call it demand dash, because you can't use underscore, so dash, demand forecast bucket. And then because the S3 bucket names have to be globally unique, we're going to use a trick. We're just going to add each one of us a different unique random number here. All right, just to make sure that we can all create a bucket. Because, for example, if we all call our buckets demand forecast bucket, then some of you will have some issues because the names won't be globally unique. So let's just add a random number at the end. Don't use the same random number as mine. And there you go. Demand forecast bucket dash random number. Okay. All the rest we will keep by default. We will keep the default options here. Bucket versioning disabled, that's fine. Default encryption, that's fine. And then we're going to click create bucket. Okay, perfect. Successfully created the bucket. So that's the bucket I created before because I was doing the lab by myself so that I can show you the results. And this is the bucket we just created. So we're going to go inside demand forecast bucket, and then we're going to click the upload button to indeed upload the data. Okay, so then you go to the folder that you downloaded from the event and unzipped live lab number 6 dataset. And then, as explained at the beginning of this lab, we're going to choose the small data, which is still some pretty big data, because it contains 5 years of historical demand for 3 items in one store. So let's do this. Let's select demand forecasting.csv and let's click open. Okay, perfect. Then we scroll down and we click upload. Once again, feel free to unmute yourself and say stop if I'm going too fast, or feel free to share in the chat, but in the chat, I won't always see it, which is why I prefer the unmute and saying stop option. Okay, so yes, upload succeeded. Perfect. Let's close this. And now we have demand forecasting.csv in our S3 bucket. Perfect. And so now we can go back to Amazon Forecast and we can import the data, this data set, from S3. Okay, so first let's give a name to that data set. We're going to call it demand underscore forecast underscore demand underscore forecast underscore dataset. Okay, dataset, and that's it. You can call it like that. Here it doesn't have to be globally unique, so that's totally fine. Demand forecast dataset, frequency of your data. All right, new interaction time. Your data entries have a time interval of how many and what? I think it's pretty obvious, but still I want to make it interactive. So what is the frequency of the data? I said it a couple times at the beginning of this lab. When I was explaining to you the data set, I was emphasizing this because this is really important when we do time series analysis. Yes, you're absolutely correct. 1 day, it's a daily frequency. So back in forecast, your data entries have a time interval of indeed 1 day. Okay. If you have a data set with, for example, 3 days interval, well, you would choose 3 days. And then if you have 1 month, you would choose 1 month here. Okay, you can choose any frequency you want, which is really good in Amazon Forecast. Okay, now very important, data schema. Okay, so because we chose the retail framework, the retail use case at the beginning in the first step when creating the dataset group, well, here we have the right format, right? We have in the first column item ID with the attribute type string, then in the second column timestamp with timestamp type, and then in the third column demand with the float type, which is exactly the format of our data set. It should be exactly the same here, basically. Okay, first column the item ID, second column timestamp, third column demand, exactly like here. Now be careful. Here the timestamp format by default is year, month, day, and hour. Here in our data set, it's actually only year, month, day. And so here in timestamp format, we have to choose this one, year, month, day. Okay. Now, okay, we're working on the small data. We're working on the small data. We're not working on the big data with this extra dimension of the store. But if you want to play with Amazon Forecast on that big data, therefore having that extra dimension of the stores, well, how would you add the stores in the framework? Let me show you. So this is, remember, the big data with that extra dimension, that extra column for the store, giving the store ID, the number of the store for each of those demands of items. And well, what you would simply do here, you would add an attribute. You would click add attribute, then you would enter the attribute name, which is store, okay? And then attribute type, of course, integer. Integer or actually string, because here they use string for the item ID, but integer would be fine, okay? So that's how you would do it, okay? If you work on the big data or even the huge data, that's how you would do it. That's how you would add the store in that framework, okay? But we are working on the small data, which has one store, therefore the column store is completely useless, and therefore we're not going to use this attribute, and I'm going to remove it. But I just wanted to show you how you can customize the framework to your data set. Some data sets in time series analysis have many other features, because sometimes the different features can explain the demand, what you want to predict. There is actually something you will see called explainability, where you can do an analysis of extra features to see how they explain, how they can help the prediction of the demand. Okay, so let me close this with the store. Okay, perfect. And now let's go back to forecast. All right, so now we have the exact right format, the exact right schema builder, which is extremely important, okay? And note that those attributes are compulsory, right? You have to have those attributes in the retail use case, in the retail framework, okay? So that's why I also made sure in the data set that the first column is called item ID, right? It is not by randomness that it is called like that. I replace it like that so that it has the exact same names as in forecast. It's very important because these are compulsory columns. I cannot change them, as you can see, okay? So very important as well. Okay, so schema builder, we're good with the timestamp format, perfect. And now let's go with the dataset import details. So here is where we will actually import the data from S3. So here again, let's call it demand forecast data set import, like that, okay? Demand forecast data set import. Select time zone, select a time zone for your data set. That's completely irrelevant because actually it's a daily frequency. We don't have the time, so we don't have to select the time zone. File type, this is of course a CSV, as we saw in S3. That's the format of the data set we uploaded in S3. Then, there you go, data location. This is exactly where we're gonna enter the location of the data within S3. As you can see, it has to be from S3. That's the first part of the path. It has to be from S3. The location is the path to the file in your S3 bucket that contains your data. And it will be the same with all the different AWS services except S3. Anytime you upload or import some data in an AWS service, it will be from S3. So there we go. Let's click Browse S3. And now we choose the one we just created, demand forecast bucket with that random number. Okay, so let's go inside. Perfect, loading object. And then there you go. You select demand forecasting CSV. Okay, then you click choose and perfect. Now we have the path to our data in S3. Okay, great. Now, very important, IAM role. So IAM is a service of AWS which allows to manage permissions in AWS, in the different AWS services. So basically, you create what you call an IAM role. You create an IAM role for a specific service. So now we're going to create an IAM role for Amazon Forecast so that Amazon Forecast gets the required permissions to access S3. And since Amazon Forecast is going to take some data from S3, well, we need to give it a role that will allow Amazon Forecast to access the data in S3 and even to write in S3, okay? So I created a role, of course, before, which is this one, Amazon Forecast execution role, but I'm going to show you how to create a new one. You simply click create a new role, all right? Then you have the choice to give Amazon Forecast permissions to access any S3 bucket or a specific S3 bucket. And here you would have to enter your bucket name, right? Exactly that name here, okay? But to keep things simple, let's just enter any S3 bucket, all right? Any S3 bucket just to keep things simple. If you want to do specific S3 bucket, you just enter the bucket name here, all right? Okay, now let's create a role. We click create role, success, you created an IAM role, perfect. So now we have everything. We are ready to not only create that dataset group, but also import our data from S3 inside this dataset group with the right schema, containing our 3 columns, just like in our dataset, and with the right frequency of our data. Okay, let's do this. 3, 2, 1, start. Perfect. And in the meantime, while it's importing the data, well, let's interact together. Let's see if you have any questions or if you missed any step, if you would like me to help you get to that step we've just reached. Amazon Forecast. Okay. And now, actually, let me show you the dataset group. Yeah, there you go. This is the dataset group we just created, demand forecast dataset group. If we click on it, well, this is the framework I was telling you about. You see what is a dataset group? It's actually a dashboard containing first your data that you import, then it will contain the predictor that you train, then it will contain the forecast that we're going to generate, and then some insights. We won't do that today. We'll just get to the forecast point, but there you go. That's your dataset group. This is the framework containing everything, your data, the predictor, and your forecasts, and even some insights. And this is where you have the explainability. Actually, for example, if we work with the big data, containing the stores as this extra dimension, here explore explainability would be interesting because it would tell us if the stores have some impact on the demand of the items. Okay, that's what it's used for. But since we don't have the store as the dimension, we only have demand of the different items for those 5 years, well, the explainability won't be relevant to us. Okay, create in progress, fantastic. Now you see it's importing the data. That's what they mean by target time series data. It's importing the time series data. And since it's the demand of 3 different items for 5 years from 2013 to 2017 with a daily frequency, then it should take 2 or 3 minutes to import that data. Yeah, 2 or 3 minutes. Create in progress. Okay, so yeah, in the meantime, while it's importing, let's interact. Feel free to ask any questions. Feel free to let me know if you missed a step. Remember, the purpose of these live labs is to all build something together, all build an application together. And here the application is a time series prediction model for time series analysis in AWS. So yeah, feel free to tell me if you missed any step, or feel free to ask me any question while we import the data here in the first step. Yeah, Jeroen, Darman, Hoai, are you all good? Avanish, are you all good with that first step? Were you able to? Okay, Jeroen, very good. Create in progress, just like me. Perfect. Darman, yes, perfect. Awesome. So very good, very good. This is a lab is very different to a course. In a course we watch the lectures, we're not very active. Okay, then there are some hands-on exercises. Some of you choose to just watch them, some of you choose to really do them, which is good. But the lab is really supposed to be active, interactive. And the way I want this to happen is that everyone builds the application so that everyone can really get their hands-on data science here in the cloud. Hoai, yes, perfect. So we're all in the same first step. That's perfect. Amazon forecast, I still have create in progress. Okay, so let's wait a little bit. We can also take a little break while we wait for this to finish. But, it should really take maximum 2 or 3 minutes now. When I did it, it was definitely less than 10 minutes. So yeah. And I did it on the small data, of course. Basically, before this live lab right now, I did the exact same lab by myself to make sure I can show you the final results, because you will see that the training will actually be quite long. Remember that when I was telling you that if we do the big data or the huge data or even the medium data, it would take a couple days to finish the lab. But here, we can finish it in 1 day. Of course, we're not going to take this whole meeting in 1 day, because I have the results for you. I already trained the model, so I'm going to show you the results once we get that second step done, train a predictor. There you go. Target time series data successfully imported, active. Perfect. Is it the same for you? Jerome, do you have it? Do you still have create in progress, or do you have it active? Just finished import. Perfect. So you have it. Awesome. What about you, Hoai? And what about you, Darmang? Do you also have it active? Is the import finished? Darmang, yes? Awesome. Okay. Hoai, you got it too? Perfect. Awesome. Oleg still in progress? Yes, of course, because of that little debug process. So it's okay. We're going to wait for you, Oleg. So then we can take a little break and restart in 5 minutes. Sounds good? Import done, Oleg. Fantastic. What time is it? Okay. You just said it. Perfect. Good timing. So I'm glad I did this while this happened. All right. So we're all on the same step now. We're all synchronized. So we're going to move on to the next step, which is to train our predictor, of course. It's going to learn the correlations, the time series correlations during those 5 years to understand how to predict the demand for the next year, which is exactly what we're going to do when we move on to the third step here, generate forecasts. All right. So let's do this. Let's proceed to the second step, train a predictor. Train a predictor, a custom model with underlying infrastructure that Amazon Forecast trains on your data sets. It's basically different state-of-the-art time series prediction models that AWS is going to combine together with a voting system so that it can give you the best prediction. And actually each prediction will be based on a distribution, with probabilities. And what we'll be getting as the final prediction will be either the mean of that distribution or the median, or even other quantiles, but we won't get into that. So there we go. Let's start the predictor training. Start. Okay, so we're going to call it, again, demand forecast predictor. Demand forecast predictor. You can choose the same name. It's totally fine here. It's only for S3 that we have to have globally unique names. Okay, then forecast configuration, forecast frequency. Your forecast frequency is, so here actually we can choose, but what is the best? What is the best forecast frequency that we should choose? Yes, Jerome, you're right. Since we have the historical demand with a daily frequency, it's relevant, it's mathematically relevant to get some daily frequency forecasts, okay? So that's exactly what we're going to do. But just know that here, you can actually choose some other frequencies. If you want to have demand forecast every month, for example, well, you could choose 1 month here, all right? But we can totally get a daily frequency of 1 day for our forecast because in the historical demand, we have a daily frequency, okay? Now, forecast horizon. Here, that's where we choose for how long we want to forecast the demand the next year, after the last date of the data set, which is, remember, I'm going to show you again. Remember, the last date of the data set is 31st of December 2017. Okay, so basically, the demand that we're going to forecast will be after that, in 2018. But we can actually choose for how long we want this forecast horizon. So which one would you like? Would you like to predict, for example, the demand for the whole next year of 2018? Or would you like to predict it for the whole next month, only January? Since we actually have a lot of historical demand, from 2013 and 2017, what, according to you, would be a relevant forecast horizon? And considering as well that we chose a forecast frequency of 1 day. So here, according to you, what would be a relevant forecast horizon, considering that we have a historical demand over 5 years from 2013 to 2017, therefore, kind of registering the patterns over the years and, the seasonal patterns. So what, according to you, would be relevant? Oleg, you're absolutely right. 1 extra year. Yes, that would be completely relevant. Yes, Jerome, that's absolutely correct. The whole next year would be relevant because we have 5 years of historical data explaining to the model the demand, okay? So it's totally relevant here to choose 1 year. And therefore, what are we going to enter here for the forecast horizon? Exactly, Jerome, you're absolutely correct. We're going to enter 365 days. You see, 365 days, which will be our different forecasts over the different days of the whole 2018 year, okay? Now, this is optional. We don't need this. Forecast dimensions, we don't need this as well. We can move on to the next step, which is about the quantile. So here, that's very important. Just know that the models, the time series analysis models of AWS are pretty advanced, and therefore they make their prediction based on a distribution of probabilities. And therefore, the prediction that will be returned has to be a quantile. So we're going to forget about the 0.10 or 0.90 quantile. The most relevant quantiles is basically, in a distribution, it's either the mean, of that distribution of probabilities, or the median, because, the median is actually a good threshold between what's on the left of the distribution and what's on the right of the distribution. And if the distribution on which is based the predictive model of Amazon forecast is a Gaussian distribution, a normal distribution, then in that case, the mean will be equal to the median. And you will see actually in the forecast that the mean is very close to the median, okay? So here, we're actually going to choose 2 forecast quantiles. First, we're going to choose the median. That's basically the quantile of 0.50. And then we're going to choose the mean. And as you can see, to choose the mean, we can just enter mean here, okay? So we will have two different predictions, but you will see in the graphs that they will be very close to each other. They will be very similar, and that's because the distribution of probabilities on which is based the predictive models of forecast will be very close to a normal distribution. All right? Okay. So, any questions on that? Should we divide data to keep some tests for our model? No need, Oleg. No, for this, we would need to use the huge data, which contains indeed a training set and test set, but this is too huge, and this would take us days to complete this lab. So yeah, I'm just using the small data here. So we don't have a training set or test set, but this is a very good question, actually. This is a very good question. Any other question on the quantiles, the mean, the median? You will see that they're going to be very close to each other. No? Okay. Okay, good. So let's proceed. Here, for the forecast quantile 1, you choose 0.50, which will correspond to the median. And here, for forecast quantile 2, you enter mean in text, just like that, which will correspond to the mean of the distribution. All right? So that at the end, we will get two predictions, two curves of predictions, one giving the mean of the distribution and another one giving the median of the distribution for each of the days. Okay, for each day we have a distribution of probabilities, and the prediction will be the median of that distribution or the mean of that distribution. We will actually have the two. It will be easier to understand when I show you this at the end. It will be more visually understandable. So now let's move on to the next step, predictor configuration. Well, actually this is optional. Remember, we don't have to activate the explainability here because we are not working with the big data having that extra dimension of the stores. But if we had it, if we were working with that extra dimension of the stores, then here it would be relevant to activate the explainability, because this would tell us if the stores have some impact on the prediction of the demand, on whether the demand of an item have some correlations with the store it is being sold inside. Okay, so that's the only purpose of activating the explainability. And sometimes you have data sets with many other features, that would potentially have some correlations with what you are predicting, for here the demand. But here we only have the demand, the item ID, and the timestamp, so we really don't need to activate the explainability. And predictor monitoring, yeah, that's not really useful for us. That's a bit out of the scope of this lab, so we won't activate it either. Okay? Then input data configuration. Here, that's where you can activate the holidays. Okay, so we won't do that. Actually, we could do it. For example, we would do it if we would know for sure that the holidays have an impact on the sales of some items in a store, which would probably be the case, right? So we could activate the holidays. But yeah, imagine your stores are in some city and that most of your customers are, people at the university or, students at school, pupils at school even. Then here, yes, we would activate the holidays because the holidays have some impact on the sales. They have some correlations, with the demand over the years. So yes, we would. But here, we don't know exactly what is being sold, what are the items, which store, which kind of store it is, who are the customers. So we won't activate the holidays, but we could, okay? And if you do this, well, you can actually choose a country of, where the holidays are. Because, in some countries, the holidays are in a different time than other countries. So for example, if you are in the US, well, you could choose United States here, okay? No, just to show you. Okay, advanced configurations, no need, this is optional. Tags, same, this is optional. All right, we're ready to create our predictor. And actually, when we click the create button, what will happen is that not only your predictor will be created, but also it will be training. It will be in training mode. Okay, and this will last a couple hours. So before I click the create button, let me know if there is any question or if I can proceed. No? All good? Okay. So let's proceed. Let's proceed to the next step and let's click 3, 2, 1, create. All right, so remember, not only the predictor will be created, but also it will be training. It will be trained. All right, as you can see, training status. Now it is in the creation process. It is being created. And then once it's created, it will be trained. And you will see that it will actually be pretty long, because I remind that the models, the time series prediction models are actually an ensemble of different models, of state-of-the-art models. So all these models will be trained, and then based on a voting system, like in decision trees or random forest, it will give the best prediction. All right, there you go, 9 hours and 22 minutes. You see, it should be actually less than that. It should be maybe 5 hours. But I was telling you that it is a big training happening. Let me just show you the performance metrics. Did we miss this somewhere? Yes, sorry, I missed this. Predictor configuration. This is where you can choose, but I left it as optional because I always keep the default metrics here. But this is where you can choose a performance metric, you see? So you have the choice between RMSE, MAPE, MASE, WAPE, average WQL. And here, actually, for the different models, it's going to take several ones, which is exactly why we saw the different columns for the different performance metrics. If we choose default and click info, you will see By default, forecast creates an optimized predictor by selecting models, as I was telling you, like an ensemble model, with the lowest average losses over the specified forecast types. You can also optimize your predictor with one of the following accuracy metrics: average WQL, weighted absolute percentage, WAP error, root mean squared error, or MSE, that's the most common one, mean absolute percentage error, MAP, mean absolute scaled error, MASE. So you see, we will have several models in this ensemble model and several performance metrics, and we'll combine all of them, and it will optimize the prediction each time, and then eventually return the most relevant prediction, the ones with the lowest average of loss errors according to these different performance metrics. Okay? All right, I just wanted to show you this because I missed this when we created the predictor. But there you go. Actually, it's a super long training. It will be less than 9 hours and 20 minutes, but it will be long. It will be a couple hours. So of course, now we're not going to wait for a couple hours for this to finish. And that's exactly why I did the lab by myself first, so that I can show you the final results. But before we do this, please let me know if you have any questions. All clear? Oleg, all clear? Okay, fantastic. So I'm going to proceed and I'm going to show you the final results. And for this, I will have to go to my other dataset group where I already have my model trained, which is the exact same model as the one we've just built. So all good for the others. Jerome, you're happy to proceed with the forecast? Now the next step is the forecast. Jerome, all good? Okay. Okay, great. Darman, same for you. Hawaii, same for you. Yes, great. All good. Perfect. So let's proceed. So in this dataset group that we've just created, our predictor is being trained for a couple of hours. So now what I have to do is go back to the dataset groups and take the one I created before where I did the lab solo by myself. Okay, so I'm going to go inside and this is my dashboard. And as you can see, everything is already ready. Well, of course, I have the data imported, which is the exact same data we imported together, and also have my predictor, demand forecast predictor hat solo, which is active with the same forecast types, first the median and then the mean, and those two performance metrics, okay? Weighted absolute percentage error and root mean squared error, okay? Perfect. So it is ready. And so now, back into the dataset group, we can proceed to the next step, which is to generate the forecast. So let's do this. Let's start the forecast generation. So here I'm going to do it alone because your predictor is being trained and therefore you can't do this step with me, but the lab is recorded and you will get the recording and therefore you can finish those steps by yourself. So now let's do this. Forecast name, I'm going to call it demand forecast. Then predictor, here we choose the predictor of our dataset group, which is demand forecast predictor hat solo, because I'm in my hat solo dataset group. Okay. Then forecast quantiles optional. That's fine. We don't have to enter them here because anyway, we entered them during the training, for the training, which is the median 0.50 and the mean. Items for generating forecast. Yes, I'm going to generate the forecast for the 3 items of my dataset, right? Remember that there are 3 items in my dataset for those 5 years during 2013 to 2017. If you wanted to generate the forecast for a specific item here, you would enter that specific item here, but we're going to choose all items. And then tags optional. Okay, and that's it. That's all you have to do. You just have basically to select your predictor that was just trained, and then you can just start. All right, so let's do this. 3, 2, 1, go. All right, create pending. So now it is in inference mode. It is generating the forecast for the whole year of 2018 with the daily frequency for the 3 items of my data set. Item number 1, item number 2, and item number 3. So in the meantime, as usual, we have 2 options. Either you can ask me some questions, or we can take a little break and meet again in 5 minutes so that I can show you the forecast, the generated forecasts. So let me know. I'll just stay here, and any of you feel free to take a break if you want to. Ah, look at that. It took, well, around 10 minutes. So yes, we have our forecast, and yes, however, the training, of course, on the other side is still taking very long. So first I have to ask, is everybody here, just to make sure, anyone is not on the break, still on the break, but still here. Okay. Darmong, yes, you are here. Good. Hoai, yes, you're here. Perfect. Oleg, you're here. Perfect. Jerome, here. Got it. Perfect. Let's do this. So everyone is here, so we can proceed to the next step. Indeed, it took 10, 15 minutes, right, to get the forecast, not the 35 minutes estimated by AWS, because they always give a good margin. But there we go. Now we have the forecast. So if we go back to the dataset group, now indeed, we have our data set imported, we have our predictor, and we have our forecast, okay? So now, in order to visualize the forecast and get any predictions for real, we have to click here, Query Forecast, okay? Then in Forecast Details, first step is to choose the forecast type. So that's, of course, the forecast we just generated, which we called Demand Forecast, okay? Then, very important, here, that's when we choose the start date and the end date for the period during which we want to generate the forecast. We want to get the forecast. So remember that we chose a forecast horizon of 365 days. Therefore, that means that we have to choose an end date at, for example, we could choose before 1 year, but we can choose the end date to be 2018 12/31. Okay, so I'm going to choose the end date first, because then you will see that the start date needs to have something specific. So first I'm going to enter the end date 2018. All right, 12/31. That's the end date. Of course, it can be any date before that, but it cannot be an end date after that, because we chose a forecast horizon of 365 days, meaning that we generated the forecast up to 1 year after the last day of the historical demand. Then for the start date, if you read this carefully, be careful. This is the start date for the historical demand you want to view. So it's not the start date of the forecast, it's the start date of the historical demand, meaning that in the final graph that we're going to have not only our forecast, but also the historical demand. And here we can choose what part of the historical demand we want to display in the final graph. And here, well, let's choose, for example, the whole year of 2017, so that we can really compare 2017 with 2018 and see if the forecasts are relevant, follow the same patterns as what we observed in 2017. Sounds good to you, or would you like to take another historical start date? Another start date for the historical demand. It's okay? Okay, good. All right, so let's choose this. Let's choose here 2017. Then 01 and 01, okay? Then the hour, we don't care. Okay, so basically, in the final graph that we're about to populate, when we click Get Forecast, we're going to have the historical demand during the whole year of 2017, plus the forecast of the whole year of 2018. Okay, it's going to be interesting. Then here, that's where we can choose which item of which we want to predict the demand. So we won't display the demand of the 3 items in the same graph. No, we will choose a specific item for which we want to predict the demand, for which we want to display the demand forecast. And so here we simply have to enter the item ID. And so we're going to have a look at the demand forecast for each of the items, starting with, let's have a look at the small data again, starting with, yeah, I have it here. Yeah. Starting with item number 1. Remember, in the first column, we have the item ID. And so that's exactly what we need to enter here. We're going to display, the forecast demand of each of the items, starting with item ID number 1. So here we enter 1, okay? And there we go. We're ready to display the forecast of the demand of item number 1. So let's do this. Let's click Get Forecast. And there we go. It is populating, as you can see. And here you go. You have the forecast of the demand for item number 1. With first here, be careful. This is the historical demand, as you can see, from January 2017 to December 2017. So this is what we had in our data set. And then here is the forecast for the whole year of 2018, from January 2018 up to December 2018, of course, for all the days of 2018. Okay? And as I told you, we get 2 predictions because the predictions are made based on a distribution of probabilities. Of course, we cannot display the distribution of probabilities for each of the days, but instead, in order to get that graphic for the predictions of the whole year of 2018, we can get those quantiles, which are the mean and the median. Okay, so for example, if we select only this, if we remove this, okay, well, here we have the predictions of 2018, the forecast of 2018 for the demand of that item number 1. And in each of those predictions, you have the mean of the distribution, of the Gaussian distribution. And indeed, if I select this again, well, as we see, the mean predictions are very close to the median prediction. Sorry, this is the mean prediction are very close to the median prediction, right? That's because the distribution of probabilities on which are based the predictions of the time series prediction models are Gaussian distributions. Okay, and you can choose to remove this as well to only get the forecast. And yes, when we display everything, for example, just with the mean forecast, well, indeed, the predictions, the demand forecast seems to be very relevant. It follows the same pattern as the year before, 2017. So the model was successfully able to catch the correlations, the patterns of the historical demand to predict the demand of the next year. Okay, it seems very relevant. Okay, so that was for item number 1. Now let's do this for the other item to see if the forecasts are relevant too. So now I'm gonna take the next item ID, which is item ID number 2 of value 2, and I'm going to get the forecast again. And same, we're going to have the historical demand for the whole year of 2017, and then there you go, the forecast of the whole year, the demand forecast for the whole year of 2018. So same, it seems to catch pretty well the patterns. It follows the same patterns in 2018 as in 2017, regardless of the outliers, of course. And again, the mean forecast is very close to the median forecast because the distribution of probabilities on which is based, the prediction models are Gaussian distributions. So yeah, did a pretty good job also for item number 2. Yes, these are all the forecasts for the whole year of 2018. And now let's do the same for item number 3. We enter 3 here. We click Get Forecast, and we will get also some very relevant forecasts of the demand for item number 3. There you go, following the same patterns as in 2017 and the years before, of course. Remember that it was strength from 2013 to 2017. So it was perfectly able to catch the patterns with the seasonality. For example, in the summer, the sales are higher, okay? Just like in the historical demand. So there you go. It did the job really, really well. And remember also that it was able to do a very good optimization work of getting that lowest error based on different performance metrics like the RMSE and the others. Okay, so yes, it's not only following well the patterns of the previous years, but also it did a pretty good job at minimizing the loss errors based on several performance metrics. So there you go. That brings us to the end of this framework. But please stay with me now, because there is a very, very important step we have to do in case you decide to wait for your predictor to be trained and then generate the forecast. It is to do the cleanup, because remember that Amazon Forecast has 2 months of free service, right? But then after 2 months, you will get charged. You will get charged low fees, but you will get charged. And I don't want this to happen. I want to protect your money. And so now, very important, we're going to do the cleanup. We're going to clean everything. But before we do this, any comments on the model, any question, anything you want to say about the results? No questions? Okay, Oleg, thanks. What do you think of the results? Do they seem relevant to you? They catch pretty well the patterns of the historical demand, don't they? Yes, at the moment, that's correct. Yeah. But usually time series prediction models are trained continuously. With every new data that comes in, it is being retrained so that it can catch the new patterns as well. Okay, so yes, now let's do the cleanup. So to do the cleanup, it's a top-down approach. We basically have to delete first what we created last. Okay, so what we're going to do is we're going to go here, and as I just said, we need to delete first what we created last, and what we created last are the forecasts. So that's what we need to delete first. So here we select this demand forecast, which is our final forecast that we generated. Then we click delete, and then we enter delete here. Okay, delete pending. Now it is being deleted, and once it's deleted, then we will delete the second last thing we created, which are the predictors. Well, our predictor. Okay, let me refresh to see if it's already deleted. Yes, you see, sometimes we have to refresh in AWS to see the update. Okay, good. So the forecasts are deleted. Perfect. Now let's delete our predictors. You see, so you go from last to first. So now the predictors. We select our predictor. We click delete. It's very important that you do this. Please do it. Once your training is done, or please do it already. You can also stop the training. There you go. Delete in progress. Okay, delete in progress. Let's refresh. Oh, you see, you have to refresh sometimes. So now the predictor is deleted. Perfect. So now let's go to the data sets, and we can directly delete this one, and you will see the other ones below will be automatically deleted. So you select the data set that you created while importing it. Then you click delete, and then you enter delete. Delete pending. Am I too greedy to already press refresh now? Yes, perfect. Dataset deleted. So now we go to our dataset group. We select the dataset group. We click delete. We enter delete, and we click delete. Your dataset group, demand forecast dataset group, and is deleting. It will be deleted very soon. So yeah, that's the last step you had to do. Then this is mine. This is what I created separately to show you the final results. So this is fine. You don't have this. But there you go. That brings us to the end of this lab. And oh, the S3 bucket, Jerome, thank you so much. Yes. So and anyway, we wouldn't have been charged for the S3 bucket because we are in the free tier. After only 1 year, we would get charged, but this would be so little because the CSV file is really, really small. So I don't know if we would even get charged for this, but yeah, you're absolutely right. Let's do the full cleanup. Thank you, Jerome, for reminding me that we also have the data in the S3 bucket. So it's very easy. You go to buckets here, then you select your bucket. Then first, you cannot delete it directly because it has some objects inside. First, you have to click empty. So you click empty. Then you enter here, permanently delete. You click empty. Exit. Now your bucket is empty, and now you can delete it. So you select it again, you click delete, and then this time you cannot click enter permanently delete. You have to copy the whole name of the bucket, then paste it inside the box, and then delete bucket. Thank you very much, Jerome. Indeed, you're right. Let's do a full cleanup to make sure that we're never charged whenever, even after 1 year. Okay, thank you very much, everyone, for attending. I hope you liked it. Please share your feedback in the event, not the event, but the post I just made in the live lab recording space. That would be fantastic, just so that the other members can know what it's about, know if it's good, know if it's going to be relevant to them. So thank you so much for attending. Thank you, Oleg. Thank you, Jerome. Thank you, Hoai. I hope you liked it. And I'll see you hopefully very soon in a new live lab. The next one will be by Luca. And then mine will come at some point, maybe in 2 or 3 weeks. I don't know. But remember that at some point in this platform, we will be giving 1 weekly live lab. So for sure, you'll see many other live labs with me. And thank you, Darman, for attending. All right. See you in the platform and see you at the next live lab. Bye-bye. I'm going to end the room now. And yes, goodbye, everyone. Thank you, Hoai. I'm glad you found the session very helpful. Thank you very much.